Hey everybody, this is Alex Merced from alexmercedcoder.com. And there's a lot of really cool stuff. If you go check out my YouTube channel, I've added a playlist for learning JavaScript. I added a playlist for learning Go programming and Clojure programming. And I'm going to be making some new videos for the Python playlist very soon. So a lot of really good stuff. And now to add on to some of those computer science videos, I want to get more in detail about design patterns. So the first category of design patterns is creational design patterns. So these are basic ideas that you're using. These are patterns in solving problems in the creation of objects. Okay, so different patterns for different problems. So the first one is called the factory method. The factory method, basically the idea is this. You have an object. Let's say the object is a car, but there are different uses for the car. Okay, so in that case you may need cars for racing, and those are going to take different parameters, and they might have different needs as far as how you construct it versus a car for just taking your family out. So you have all these different situations, but you don't necessarily want to create a separate class for every situation, because eventually you're going to end up having so many classes that it becomes tough to manage all these separate constructors. So now you decide you want to add a method to cars in general. Yeah, you could have a parent class that you edit, but it gets a little cumbersome. So the idea is to have this one, you have your class that is cars, but then what you do is you either have another class or function that helps you create the right car for the right situation. Okay, and that is your factory. Okay, so instead of just doing new object, okay, and creating a new instance of car and then passing all the parameters into the constructor function, okay, because again, you might end up having 20, 30 different parameters that would need to go into that constructor function, and that gets a little crazy. Okay, and then plus, what happens is that if you just let the person decide what all the parameters are without any kind of pattern, sort of control flow, they may be able to create things you don't necessarily want them to create. Okay, or have a tougher time using it. So what you do is you create this class that is the factory. Okay, so in this factory, so imagine that you have your class car, and now you have a class called car factory. And that car factory literally has methods to create different types of cars. And depending on which method you call on the factory, it'll create a car with the right specifications, making it much easier to turn out the right objects that you need. Okay, with the right specifications, and taking a lot of the burden off the person who's using those objects from your library. Okay, because at the end of the day, the point of a lot of these patterns aren't for you, the person who's writing the code per se, or creating the library. It's more, if I create this library that has these objects for other programmers, how can I make it more usable for them, but still have all the features and flexibility in that object that I need? And so that's what sort of you're thinking of with the factory method. You're saying, okay, well, I have cars, and cars, you can literally create all sorts of infinite possibilities of cars, but to make it easier for that person who's going to be creating these car objects in their program, let me create this car factory that'll have methods to create a lot of sort of basic ideas of cars. Cool. Now, what if you were talking about all sorts of different vehicles, cars, boats, whatnot, and you had separate objects for cars, separate object for boats, separate object for helicopters, planes, and you're like, you know what? Let me just create all my methods for constructing these into one factory. So then you had your vehicle factory class that had methods for creating cars, airplanes. This is where we start getting into abstract family, where instead of you having a factory for creating a particular object, you have a factory that creates all different types of objects. Okay, so that's abstract family. Okay, then you have the builder. Okay, this was a pretty interesting one. So like I mentioned, you can end up having a really complicated constructor depending on how complex your object is. And can you imagine that every time you want to create a new instance, you have to type in 30 parameters when you call that constructor? That'd be crazy. So instead what you do is you create a builder class, okay? This would be more like creating an assembly. So going back to the car analogy, this would be like creating a assembly line object. An assembly line object will have lots of different methods, okay? And basically you would call each method to create a different part of the car, kind of like an assembly line. So you might call the first method that would construct the frame of the car and has a handful of parameters. So you're only setting like 2 or 3 parameters at a time. And then you call the next function, which is maybe the wheels or the frame. And basically after you call all these functions, you've loaded up all these parameters into the class that you can call the last function that actually creates the new instance, that creates the final car object, but now has all those parameters loaded in because you called all these functions that basically set up the stage. So you built it step by step by using these methods. That's sort of the builder method. Okay, so you're creating a really complicated object by breaking down the creation process into several different steps and creating a class that has those methods for those individual steps. Okay, then there's a prototype. Okay, what if you have objects? There's memory benefits and whatnot. Like, what if someone created a object? So let's say I created a car, and basically the car is this instance of car already has all the properties that I need. Okay, and I don't need to necessarily, and it's maybe less efficient for me to go actually just create a new fresh car with the same parameters when I can just make a copy of that car. Okay, this is called prototyping. So instead of creating a function or a class or a method that creates a new instance of the car, what you're doing is you're cloning an existing object. And this can be done by creating a method that essentially does create a new object, but instead of having the user have to enter in all the same parameters that already exist in the existing car, this method will take the existing car instance, copy all the parameters, and then add it to a new instance of car. So literally you're cloning the car. Okay, and this makes it easier when you need to clone a particular instance. So I can imagine this for like a role-playing game. Okay, you may have you have a villain object, and you have a factory class that creates villains. So you created a goblin, but now you need lots of goblins, and it'd be silly to just sit there and have to enter the same parameters over and over again into that factory. So instead you have a separate function that'll now make a copy of that goblin you've already created and populate the game with all the goblins. Okay, so that's the prototyping or cloning type of design pattern. So factory, we're building this thing that'll churn out the object. The builder, we're creating something that gives you steps into building the object. Prototyping, we're creating a way to clone the object. And then there's a singleton. Okay. So for example, there's only one boss, okay, one final boss in a video game. So while there may be many goblins, there's one final boss. So what you want to do is make sure that only one final boss can be created. Okay, so this is a class that works to try to make sure that there's only one instance of the class. So there's different ways you can do this. You might make the constructor private, which means you can't call the constructor from outside of the function. Okay, so then the only way to do that you'd have to create some sort of static method to create an instance, in a sense. And again, if you're not familiar with the term static method, this would be a static method is something that's called on the object. So you're not calling it on an instance of the object, you're calling it on the object. So it's if I were to create a static method for a dog class, I wouldn't call Sparky or Spots that method on Sparky or Spot. I would call it dog.that method. Okay, so you might create that static method that'll create that one instance, but every time I run that function again, it'll pick up that one instance has already been made. So you might have a Boolean, there's different ways you can do it, and it won't let you create another one. It'll just say, hey, here's the one you already made. It'll just return the one you already have. So that way you've only created one final boss. That's referred to as a singleton. The idea is you're creating a pattern that'll provide that only one instance of this is created. Okay, so one final boss, one ledger for the company. Okay, we don't want people creating a bunch of different accounting ledgers for the same company. So we want to make sure only one is created. There's also different situations where you only need one of the object. Other people may need that same object, but they may only need one instance of it in their situation too. Okay, and you still want to create an object because you want to have a constructor that'll help them construct it to their needs. Versus, let's say in JavaScript, where you could create an object that would also achieve the singleton objective, where you create an object instead of a class, because you can essentially put everything you need into a JavaScript object, and then there would only be one, and you could theoretically clone it. But aside from that, You can't instantiate new ones. Or you can just create a class, have the constructor what you need, but then you make it where that constructor can only be accessed through a function. That function does sort of a if check, an if statement. So if the Boolean hasn't been made true, then it creates a new instance of that object, and then after that the Boolean is now true. So then the next time it runs the function, it'll pick up on that this function was this object was already instanced, and will just return you the already existing. And that could be done with like pointers and whatnot, because when you pass parameters. But the point is that the actual pattern of the solution. So hopefully this helped you understand some of the main creational design patterns. So again, factory, builder, prototype, singleton, a little bit better. So my name is Alex Merced from alexmercedcoder.com. Have a great day and enjoy.